GDIS is a network management system with more than 20 years of history that serves two of the largest companies in the electrical power sector in Brazil. It currently has more than 10,000 users and serves more than 500,000 kilometers of extension of the power grid, serving more than 8.5 million customers in the country, corresponding to 15% of the Brazilian market. Formed by 10 different modules, GDIS blends integrations with other systems and covers the whole process of the electric power distribution. The system module responsible for the geospatial visualization of the network and its assets is called GE. Data is received through integrations with other GIS systems. The network is colored by feeders, and each element has a specific image to represent it. The map has some basic features: navigation, zooming into a specific area, clearing the map markers, updating the layers, activating Google Street View, changing to the road and satellite map, and returning to the previous view. To view an area in more detail, simply use the Zoom tool and select an area. Then, you can choose elements to view their details. Each element type has a set of details and a set of operations. They all allow for the location and view on Street View. There are some basic map display settings. Change the map background to Google Maps, OpenStreetMaps, satellite images, or on mapping. Enable and disable viewing of specific layers. Each map type has a valid configuration. Maps can be divided according to their functions, that is, which elements will be displayed. The network can be shown in two formats, operated or planned. The first one reflects the situation of the network in real time, with the operations of the elements. The second is the unmodified state of the network, the way it was registered. Network analysis is done by visualizing the network of only one feeder at a time. Or, for a more specific analysis, other feeders can be included. The power grid can be marked with signs that indicate special operating situations, and also to indicate that there are special clients in the network segment. Temporary elements can be registered to assist the operation of the power grid. They are also registered to reflect any real temporary elements that are connected to the network, such as mobile generators. The network is imported from external applications from projects that modify it. These projects are applied after the analysis of specialized users, and they override those parts of the network that are free of operations. Network modifications reflect on all GDIS modules. For elements that are electrically connected to the grid, there are options for highlight the feeder network, upstream or downstream of the equipment, list the customers connected to the element, insert a new sign with operation information. The power grid can also be viewed in an orthogonal diagram. Through this model of GDIS, detailed information of the elements are available, and the complete visualization of the network of a feeder can be seen on the screen. Highlight of the circuit is easily visualized, and also the signboards and the clients of that block. You can find elements from a forward search and also change to the operated or planned view. As a way to optimize fault handling, it's possible to create sequence of operations on the network. They can be executed remotely by the operator itself, or by sending them to the field to be executed by a team using the mobile module. Each sequence must have a network element as a reference, and each item in that sequence is also georeferenced by a network device, and which operation will be performed. An execution date is informed, and which executor is. Other information may be included per item to assist operator control. Execution of the items reflects in real time the status of the network, which can be verified by all users with access. Like that, network operations attack other systems processes, helping to select customer complaints that may be affected by such operations. The clients being affected are listed with each execution according to their state at the current time. This helps the operator to size up their actions. In major storms or atypical events, operators must create sequence of operations to restore power supply and organize the actions that must be performed in the field for circuit normalization. Sequence like this can be filled before in the system and recovered later, which speeds up the work of the operators. In addition to the sequence of emergency operations, it's possible to create sequence that will be executed on a scheduled basis. In order to perform modifications and maintenance to the grid, you may need to disconnect part of the power supply, so a sequence programming process can be done in the PM module. Applicants can register requisitions of intervention on the network. Then they are analyzed by technicians who can check how many customers' units will be affected and if there are special customers impacted. It is also possible to analyze the impact on power quality indices. Consumers who will have interrupted power supply should be advised of such scheduled outage. This warning can occur through letter, email, SMS, or phone call. With the assistance of simulations in the network, the programmer creates a sequence of operations that will have the least possible impact. The load transfers and the load curves of the interrupted sections can be analyzed. Finally, after approval, the sequences are sent on the programming date to be executed in the network operation module. GS is the module responsible for controlling and responding to customers' complaints. Complaints are received by integrations with the customer service module or external integrations, such as SAP CCS. They are sorted from an intelligent algorithm that transverses the network to look for other complaints and thus to predict the location of the problem. In this way, the operator easily selects a team to solve the problem in the field. The servers are identified by codes that indicate their type and priority. That helps the operator to select which service should be dispatched first. The network is interpreted as a graph, where some nodes of it are classified as points of accumulation of complaints. Through a number of complaints configured, the system reclassifies the set of complaints and moves off level in the network, indicating where is the most probable place of failure. The job deadline is decided by the type of the service and also by a rule of geographical location. This area is a classification made by the Brazilian federal agency that oversees the country's electricity distribution companies. It is possible to contact consumers to check the status of the complaint. The callback can be performed automatically using an integration that makes the calls through an IVR. Or they can be selected by attendant who will contact the customer. After the answer, the complaint can be cancelled if they do not need any treatment, or they go back to the dispatcher's selection to send to a team. The system can predict possible fines that can be generated by the delay in service attendance. That information also helps to prioritize the service. In addition to the complaints, commercial services can be also taken care. The dispatcher filters what he can see on the screen through a dispatcher profile. You must also choose which places should be selected to view the service to be treated. In this way, a company that works in a large area can divide the work of its operators, and each one can focus on a specific area and a specific type of service. Delivery of the service to the team can be done through integrations with the field service module. The messages are sent by 3 different communication channels: GPRS, satellite, or direct connection. Communication can be online and offline. This means that teams can leave the office with mobile devices loaded with the service they will perform throughout the day. And at the end of the day, the executions are informed to the system. Or they can have online communication to receive emergencies and communicate with the operations center by messages. Communication with the teams is facilitated by a screen that controls all available teams. Also, system warnings can be viewed in this screen. Servers and teams can be viewed on a map. On the map, there are similar functions for dispatching services. The status of the field executions are updated in real time, so the control of the teams and the next calls can be monitored by the operators. There are options for grouping the pending services into lists, so they are sent to the teams at once. It is possible to schedule a list of services in advance, and they are sent one by one to the team as it ends an execution. The Service Management module has several other features to improve customer service. There are several reports that assist in daily analysis and improvement of care strategies. The main goal of a utility company that works with electricity distribution is reduce the interruption time of power supply. In addition to the financial loss, the main quality indices are measured through the interruption time. Complaints that cause disruptions as well as execution sequence of operations in the electric network generate items that can be processed after its execution. The disruption treatment is important to ensure the real occurrence times of field events as well as the exact selection of discontinued consumers. Service can be carried out by own or external teams. The dispatchers of the service can also be external users. The types of service that external companies can perform are configured in the system. The calculation of remuneration of the external teams is carried out by the module of appropriation of services. A period and contract must be selected, and the calculation is performed by the system. The responsible person can correct and include extra payments if necessary. It is also calculated the overtime and the fines in the case of non-compliance with some deadlines. Operator training and the simulations of past events are performed in the training environments that have the same information as the production environment. The maintenance module is responsible for inspecting the network, prioritizing maintenance, and organizing the work that needs to be done to keep the power grid and its device in good working order. In order to comply with Brazilian legislation, quality indexes are treated by a specific module. Through it, reports can be made to track the performance of the company. For more information, please visit our website and contact us.